Hello? Am I loud and clear? Hello?
Yes. Good
Yes,
morning.
sir.
Yes, sir.
Yes.
Okay.
Yes, sir. Good
Yes po.
morning.
Okay. 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 Good morning and welcome to the 26th Summer Institute in the Natural Sciences and Mathematics, or SINSM, with the theme Strengthening Senior High School and Tertiary Mathematics Instruction 2.0. My name is Celestino Jerome Picar, or simply call me Celeste. I will be your facilitator slash MC for this morning. Before we continue in our program, may we remind everyone to please observe the following netiquettes. Um, so, sir, please. Okay, clear. Kita ba? Okay. So, number one, please turn off your microphone and webcam during the talk. Two, please post all your questions in the chat. This will be asked by the moderators at the end of each talk. Towards the end of the last presenter scheduled for the day, the link for the evaluation form will be posted. This will also serve as your attendance for this event. Certificates will be awarded to attendees who attended at least 75% of all talks in the workshop. Okay. To formally open this event, may we welcome the chairperson of the Department of Mathematics and Computer Science, Professor Rizabel Corsino Adawe, for her opening remarks.
Thank you, Celeste. Good morning, everyone. I hope you are comfortably seated in front of your gadgets. To all, good morning. Good morning, fellow educators, researchers, and administrators. Sa mga Ilocano, naimbag ng agsapa kada tayo amin. Sa mga Pangasinense, maabig yakabwasan at ikatayon amin. In Tagalog, magaganda po tayong lahat. Pero good morning. May I give you a brief overview of this event? The Summer Institute in the Natural Sciences and Mathematics, or SINSM, is an annual activity of the College of Science of the University of the Philippines, Baguio. It aims to update teachers on recent developments and innovations in the natural sciences and mathematics. It aims to enhance the pedagogy and research skills of secondary and tertiary teachers in the Cordillera and its neighboring regions. To our dear neighbors, you are all welcome to this event. This year's SINSM or SINSM is being conducted virtually via Zoom video conferencing, which will be streamed via YouTube and Facebook Live. This year's SINSM has 4 clusters from the 3 departments and human kinetics program of the College of Science. We have scheduled order lectures in natural sciences and mathematics this month of May. This May 6 until May 8, you will listen from the Department of Mathematics and Computer Science, or the DMCS. You may also attend lectures from the Department of Biology on May 13 to 15, from the Department of Physical Sciences on May 19 to 21. And from the Human Kinetics program, you may listen to their lectures on May 25 to 27. The registration process and more details are posted on the Facebook page. You may go to wawa.facebook.com/sinsm.upbaguio or email us at sinsm www.upbaguio@up.edu.ph for inquiries. Maybe you have to memorize that. At this point, I sincerely thank all the SINSM Secretariat members from the three departments and from the Human Kinetics program under the College of Science. May I read their names? We have Jonas Paul Viernes, Anthony Meneses Pasion, Dane Froli Soriano, Geno Beba, Windel Santos, some of these are screen names, Jumps Mendoza, Christian, Crisostomo, Raymark Eleje, Geno Ray Pagaduan, Jessica Talanghoy, and Brian Martos, and last but not least, Mary Joanne Habon. Thanks to all your hard work and congratulations in advance. I would like to thank the department chairs of the three department chairs, Dr. Rolando Hipol or the chair of the Department of Biology, Dr. Ofelia Hiron, the chair of the Department of Physical Sciences, Professor uh, Fernando Florendo, the coordinator of the Human Kinetics program, for making this event a success, the holding of this SINSM 2021. Okay. And also the Dean, of course, of the College of Science, Dr. Gina Javier. Our Vice Chancellors, Dr. Rose Gutierrez, the current Vice Chancellor for Academic Affairs, and the Chancellor, Dr. Corazon C. Abazi. And of course, our beloved previous Chancellor, Dr. Raimundo Ravillos, for the continued support to this activity of the College of Science. I would like to thank all the faculty members of the department, the lecturers, the teaching associates, and research assistants. Where without them, this event would not be a success. And thank you to all UP Baguio administrators. This year's theme for the 26th Summer Institute in the Natural Sciences and Mathematics is strengthening senior high and tertiary mathematics instruction 2.0. Participants can select from 4 tracks of lectures. These include A, pre-calculus and basic calculus. B, general mathematics and statistics. C, differential equations. And D, basic Java programming and agent-based modeling. Each track will provide participants with the opportunity to improve their mathematical knowledge and teaching strategies on the specified subject through a series of intense lectures. By the end of the program, its participants should clearly understand the fundamental concept of his or her chosen track, as well as have improved teaching skills and instructional techniques. Additionally, the department will host 2 plenary sessions in mathematics of data science and an introduction to statistical modeling in R. May I put things in order before we go to the main event of this morning? You can receive only one certificate for this, for the completion of this event. So we should complete the 75% of a total lecture hours over 3 days, which is approximately, or I guess more than 9 hours. You need to choose and religiously attend to one of the tracks. So far, we have registered 1,147 participants for the 4 track, 282 for track A, 356 for track B, 258 for track C, and 151 for track D. So this is the statistics as of yesterday afternoon. However, we can only accommodate 300 for each of the Zoom meetings. Participants over the 300 limit may follow us on Facebook or YouTube. So before the afternoon session begins at 1 p.m., may we request you to decide on the tracks that you have chosen or to register if you have not registered. And you can also decide to transfer, especially those who are registered in track B, the general mathematics and statistics. You may transfer to track A. You have eight slots. Track C, we have 42 slots. And in track D, we have 149 slots. For
Hello? Okay. And,
Ma'am Vel, nag-mute yung mic mo.
sorry na pindot. I accidentally press the the unmute button. Okay. For hindi saan hanggang saan ako? For the tracks,
Start
no?
mo dun sa statistics. Ulitin mo dun sa statistics.
Sa statistics. Okay. So we request the participants on the track B, okay, to transfer to track A. There are still 8 slots, no? And then to track C, we have 48 available slots. And to track D, we have a lot more, 149 slots. Okay. So for more inquiries or for your inquiries, you can email us at dmcs@up.edu, dmcs.upbaguio@up.edu.ph, or you can go back to the Facebook pages. May I also make few announcements. Bibilisan ko na lang. We offer graduate courses in mathematics, the MS Mathematics and PhD programs. The deadline of admission is scheduled June 30, 2021. There are limited DOST scholarships. So this is on a first come, first served basis. And of course, the merits, your qualifications. Okay. For all the incoming graduate students, we offer intensive training programs, ITP 2021, for free. This is about 48 hours lectures in the core courses of algebra and analysis. So for those who are planning to enroll in the MS and PhD mathematics program, please do submit your admission requirements early so you can join this intensive training program. Okay. Now, for the incoming event of the National Convention of the Mathematical Statistics, MSP. Ano nga yung MSP? We have the National Convention on May 15, May 22, and May 29. You can also go to the Facebook page of the MSP. For your membership to the MSP, we will send you the online registration. Okay? So registration for this year is online, but before you receive your certificate of membership, you have to upload the proof of your membership payment. Membership is only 300. Okay? Hindi po ito scam, no? You can deposit your membership fee to our BPI account. The BPI account is a joint account of 3 board members. 3 board members of the chapter, Region 1, Region 2, and Region 3, including CAR chapter. For those who are not from Regions 1, 2, and 3, and CAR, please contact your respective chapters, because you have to register to your chapters, no, corresponding chapters. Okay. The membership will be emailed to you. Okay. So for any questions, you may also put into the chat box before we do the plenary. Okay, but it's 10 o'clock, no? So without so much ado, again, let's welcome all the participants. We are 247 in the Zoom meeting. I hope we are also on YouTube Live. For those who want to join us in the Zoom conferencing, please do register to the different tracks, the 4 tracks, so we can accommodate you. Okay. All right. So our participants are from all over the country, from regions 1, 2, 3, 4, and even from the rest of Luzon, Visayas, and Mindanao. Okay. And so with that, we warmly welcome you to the SINSM. Don't forget SINSM, SINSM 2021. And we look forward again seeing you next year. Congratulations for being accepted to the DMCS cluster. Okay. So again, good morning. Naimbag nga daw kadatayuan. Celes, thank you.
And hello. Thank you, ma'am. Well, for that very inviting opening remark. We may now proceed to our first plenary talk. Okay. Here at the Department of Mathematics and Computer Science, University of Philippines Baguio, we live by our devotion to building and improving expertise in all areas of mathematics. So it is with special excitement to introduce to you our first plenary speaker for this annual event. Our speaker for this morning earned his Bachelor of Science degree in mathematics with honors here in UP Baguio in 2010. His service to the people by giving quality education started in 2010 by becoming a lecturer, while his passion for the mathematics remained as he obtained 2 Masters of Science degree in mathematics in 2013 and 2016 from UP Baguio and the University of Iowa, USA, respectively. It is also at the University of Iowa where he strived further and received his PhD degree in mathematics in 2019. His stay at the University of Iowa amplified his interest in applied algebraic topology, persistent homology, network analysis, and data science. These interests lead to his several international publications, such as a topology in for random forest classifier for ECG classification, intrinsic hierarchical clustering behavior recovers higher dimensional shape information, and Lumawig, an efficient algorithm for dimension zero bottleneck distance computation in topological data analysis. Alongside gaining international publication awards in 2016 and 2020. He is also an active speaker for several international conferences, including Asia Pacific Seminar on Applied Topology and Geometry, IEEE International Conference on Machine Learning and Application, and International Congress on Industrial and Applied Mathematics. Currently, he is an associate professor here in UP Baguio while also serving as the head of the recently created Topological Data Analysis or TDA research group. In a mentor to young graduate students. Without further ado, giving us his talk entitled Beyond Numbers, an introduction to the mathematics of data science. Let us all welcome Professor Paul Samuel Padasas Ignacio. Thank you.
Magandang hapon sa ating lahat. Salamat Celes sa introduction. Let me share my screen. Nakikita po ba ang screen ko and naririnig ako ng malinaw?
Yes, sir. You're loud and clear.
Alright, maraming salamat. I will occasionally ask you to use your reaction features, lower portion ng Zoom, so I can get feedback every now and then. So first, I'd like to thank the organizers of the SINSM. It's been too long. I've been really excited to give this plenary talk since last year. Unfortunately, we were not able to hold the SINSM because of the pandemic, but here we are now, and we're trying to make up for the lost time that we could have spent sa pag-share ng extension work na ito. Maraming salamat sa DMCS in particular for inviting me, and I'd like to thank everyone. I think, ilan na ba tayo ngayon? Let's see. 264 sa Zoom, and sa YouTube, there are 79 people watching. So I'd like to thank everyone for being here today. I'm really excited to be with you all and share what I know and how I appreciate data science this morning. All right, so my talk is entitled, okay, let me share, go to full screen. All right, medyo may delay lang, pero ayos lang yan. So today I'll be talking about a very terse introduction to the mathematics of data science. Really, I'll try to cover. Hello? Okay, kala ko may tanong. Sige. I'll try to cover some of the basic mathematics, at least at the foundational level, how mathematics is used to really make the thing work, data science work. So as Celeste said, I'm Paul. I'm a faculty member at UP Baguio. I've been in UP Baguio for a really long time now, and I'm really glad that I'm able to give back through extension work like this. Here's the outline of my talk. Okay. Oops. There you go. Here's a quick overview of what I will be covering today. So first, I'll give a brief introduction, or at least state my two objectives for this talk. Do not expect that this will be a very detailed introduction to data science, because this is only a 90-minute talk. But if you'd be interested after this talk, I'm open to communicate with you to perhaps further discuss and explore ways on how we can do research, or at least learn more about data science. Then I'll share how I view data science, how I appreciate data science, the mathematics behind it. Again, it won't be in full detail, but at least my goal is to impart a general idea of how it's used in the full framework of data science. In particular, I'd like to cover two important examples where I will try to be detailed, at least in the application to Google's PageRank algorithm, and a very brief intro to neural networks. Okay, so that's the outline of my talk. All right, so before we start, let's do some quick exercise. If you could please go to this link, https bit.ly/3, I think that's 26N6N. Please click or go to this link and then answer. There's just one question on the survey. I would have wanted to do this in a different way, but I'll share that a bit later. But please go to this site, and then there's only one question. Please type in the city or town from where you're joining us today. Or if you would like to represent your institution, please do so. So instead of typing in your city or town, gusto ko lang pong malaman kung sino yung mga kasama natin ngayon and ano yung ating constitution this morning. So please go to the website. It's a Google form. Just answer one. There's just one question there. And please, I'll give you maybe 2 minutes to do this. All right. Okay, meron ng mga sumasagot. Ang bilis. There are now 31 responses. Okay. What I would like to do with this data is I'd like to make a word cloud and share with you para alam nating lahat yung constitution, yung sinong kasama natin ngayon sa pag-uusap natin about sa topic na ito. And sabi nga ni Ma'am Bell, this is a national event in the sense that it's open to everyone. But at least I would like to get a sense of how distributed we are, or the areas that we are able to reach through this extension service. All right, so we are now, maybe I'll give 30 more seconds. We're already at 105. Okay, I would have wanted to do this in a more data sciencey way. You can. I would have asked you to, if you had a Twitter account, to tweet hashtag SINSM 2021, and I would have shown how you can actually collect data from Twitter. But my application for that app didn't make it in time, so I'm using this survey instead to gather the data. But that would have been nice, but oh well, we'll do with what we have. Okay, so we currently have, let's see, 157, 161, maybe 20 more seconds, then I'll try to generate the cloud and then share with you the results. All right, let me pause for. Okay, may humahabol pa po. Sige, hintay. Okay, so let me stop sharing for now and then go to my other computer and then, okay. So here's our, hopefully you can see this. Okay, ito po yung distribution natin ngayon. So most ng participants natin, Baguio City and Baguio, of course. And then, yay, Kabanatuan is here. Medyo nakita ko yung ilang mga teachers ko ng high school. So hello po. Salamat sa pagdalo. We have from Tacloban City, Taytay, Tarlac, Zambales, and then my representative from NDSU, City of Batac, Capas Tarlac. Yan, hopefully you can see. So maraming salamat. Mukhang karamihan sa ating participants today came from Luzon. But I think I saw, let's see. There's one from Iligan. Yeah, Tuguegarao, and then Batangas, Vigan, Quezon College. Okay. Ayan, salamat po sa pagdalo, and I just wanted to know the profile of the participants today. So that's why I wanted to do this exercise. All right, so let me continue now to my talk. Okay, let me go back here. All right. Then share. Okay. Go to full screen. Okay, all right. So again, salamat sa pag-indulge sa aking request. My objective for today would be twofold. So one is, okay, I would like to provide a general but functional understanding of the framework of data science and the integral role that mathematics plays with it. So again, it's not my intention to explain every bit of detail how mathematics works in this field, but at least a general understanding of how it makes, kumbaga, how it serves, it plays the role of the gear that keeps the machine going. And my second is to illustrate this one in fine detail through the examples, the mathematics involved doon sa dalawang example na i-cover natin. Two very important examples in data science and machine learning, the PageRank algorithm of Google, and also in neural networks. Okay, so those are my goals for this morning. So what is data science? This is how I appreciate it and understand it. And so it is the study of the systematic extraction of non-trivial patterns and information within data that can be useful in making sense of the characteristics and the overall structure of the data set. So if you think about it, it is largely similar to statistics, right? So if you read this working definition that we'll try to adapt today, it is very similar to statistics, and that's because in part data science is, I would say, 1/3 of data science is statistics. So that's why there's a big intersection with the goal of statistics with data science. Historically, data science really developed with statistics in tow. So that's why on paper, they are very similar. Okay, but this is how I would like to imagine data science. So imagine you're watching the night sky, and imagine the stars as data. Sometimes if you look at this night sky, you're a bit overwhelmed with how much you see, right? How many stars there are, and in a sense, data science tries to capture that. So we now live in a time that we are overwhelmed with data, and sometimes we don't know where to look at or how to process it. And so comes here data science, and I would like to put the imagery of the telescope here, that we could use it to somehow zoom on something and try to make sense of that particular portion of the sky, or at least a way to describe a portion of the large data set. So going back to this definition, data science is really a common ground of three domains, three spheres of knowledge. So we have mathematics, and here mathematics includes statistics, and then it also marries with computer science, and also expertise from the field. So this domain expertise includes any application field of these two spheres, mathematics and computer science. So for example, one popular domain of expertise. So by the way, this includes practical and operational knowledge of a specific field. So for example, business, in the business domain, gamit na gamit yung data science doon. So hindi enough na meron tayong theory, di ba, and skill sa computation. We also need input from an external, or I would say practical expertise. So ito yung usual na representation ng data science. It is the intersection of three spheres of knowledge. And itong mga intersections sa dalawa, halimbawa yung mathematics at saka domain expertise, this is the traditional statistical research. This is how we traditionally would use mathematics to and apply it to real world problems. And then the intersection of mathematics, statistics, and computer science would be machine learning. And then this one would be the traditional data processing or programming or data mining. And so if we marry everything, that's what I believe, and I concur to this idea that data science is the intersection of all three. And so for today, we would focus on just one portion of it, at least as a part na to. That's why the title is the mathematics of data science. We'll try to cover and see how mathematics fits into this framework. All right. So in a way, the ecstatic development of data science, and I'm sure you will agree that this is really young, and hopefully many of you have encountered this term before, data science. This is really, I would say, less than 20 years na nagkaroon ng boom sa development ito. And it's really in response to a welcome opportunity and a desperate need. So what are those? So the increased capability and efficiency to gather data from multiple channels at this time also meant that we can now collect information that is much more complex than what we are used to. So dahil sa development ng technology, mas madali na ngayon kumolekta ng data, mas marami at mas complicated yung data na nag-generate natin. So yung opportunity na brought about by the new advance in technology also brought about a desperate need, because we have, especially in the industry, right, in different industries, they found themselves swamped with, I would say, data haze. So they have too much of a good thing, but they did not have the required horsepower, in quotes, to make sense of it. So they have the data. We can collect data now. We can store it and we can organize it, but we don't have the capacity to really fully understand what we gathered. And so that's the need that that data science tries to fill in. So in short, the volume, velocity, and variety of information that we can now gather are surpassed only by our increasing need to make sense of it. So that's how I always picture data science. So it's a response to an opportunity that came with the development of technology, and also because of a desperate need for a tool that would allow us to make sense of what we have. Okay, so what can we do with data science? So these are just some of the typical or popular projects that people work on. One and like I said, the industries really responded to this development because if you have a business and then you would like to develop your business, or at least in the market, right? And you're able to collect data, and you would like to get information, useful information from that data. So one thing that people do is, once they collect, or at least in the business, in the industries, is to come up, or at least ano ba sabihin yan? Get an idea of the naturally existing groups sa customers nila. So customer segmentation, ano yung mga natural groups, and how can we better respond to the needs and wants of our customers. So that's one thing. Also is web traffic forecasting. I'm sure you've used Waze or Google Maps. Real-time information on which routes would be best to take, right? Detecting fake news. This is really interesting. So data science is able to screen through and decide. So halimbawa may dumating na isang post or news article. Data science is able to scrutinize that piece of information and decide whether it is credible or not. That's one other thing that I really enjoy looking at that application. Another one is, this is very new, internet troll, the same idea with detecting fake news. Stocks portfolio management. I've seen an application where your input would be different stocks, and then susundan mo yung time series niya for some time. And then from that, say for example, you have a pool of 30 stocks na binabantayan, which one of those will be best to invest in, and which ones should you maybe stay away from at this particular time. So that's also one thing, one exciting thing. And then also, I've also seen work on predicting financial crashes, and they medyo pagbabalik tanaw na ito, they developed the theory and then they applied it to the data in 2009, and they were able to identify some features that led to the 2009 global financial crisis. And there are many more. So these are just some of the first examples that if you Google data science projects, these are some of the things that you will see na madalas. Okay. So, all right. So, ayos pa po ba ang ating discussion so far? Again, please use your reaction features just for me to get feedback. May masyado bang mabilis ako magsalita? Hopefully, naiintindihan naman yung mga sinasabi ko. All right. Okay. Medyo nag-a-adjust din ako sa ganito pa rin na setting. Medyo nami-miss ko yung personal interactions sa students sa class. But hopefully, we can move on. Okay. All right. Maraming salamat po sa feedback. Here's the big picture that I want you to adapt this morning. So again, my main goal for this talk is to give you a general overview of how mathematics is used in the framework of data science, and in finer detail doon sa dalawang important examples. But here's the big picture that I want you to consider this morning. So we have big data, right? So we are able to collect big data and we want to analyze it. So the next step after that would be perhaps organizational stuff, cleaning. But then the next step would be to develop a model, right? So what mathematics do we use there? We'll talk about it in a bit. But after developing the model, whatever that means, then we try to optimize the model and to minimize the errors that we have, or at least the bias that we integrate in the model. And then after fine-tuning it, we try to analyze the model and then interpret the results that we have. So what I would like to do is in each step of this big picture, what is the dominant, I would say, dominant math or that we need, or at least we use for each step. So for at least for the first two steps, data management and modeling would involve largely linear algebra and statistics. And I guess the statistics would be obvious in this part, right? Because when we develop models, we really have to involve statistics there. But where does linear algebra come from or come in? And I'll talk about it in a bit. And perhaps you get an intuition why that is so, since we're dealing with big data. And a natural way to organize big data would be matrices, I guess, and vectors. So that's where linear algebra comes in. And then the next step in the optimization. So if you think about it, what mathematics deals with optimization, and I hope that as you still remember your college mathematics, a very a basic idea for optimizing would be to just use calculus. So calculus is also involved in this area, at least vector calculus, so higher dimensional versions of the calculus that we learned in at least in analysis. And then the last part would also include statistics. Okay, so medyo mas magfo-focus ako sa dalawa na ito kasi again ang goal ko would be to explain or at least share, di ba, how ang gusto kong image na ma-develop how mathematics plays the role of the gear that keeps the object turning. So yun yung imagery na gusto kong i-develop today. Okay, so sa sa big data generation, organization, processing, transformation, linear algebra, we use linear algebra because if you think about it, once you start working on the data, a natural way to organize it is in terms of arrays, right? So if you think about an observation may have different variables, right? Many variables, in fact. So it's natural to think of one variable as one coordinate. So this array, for example, would represent one observation in your data. So it's a natural thing to do, especially when you do the programming, step. It's arrays that we use, or vectors if you want, vector in R to the n, with each coordinate representing one variable in your observation. And so data are stored, processed, and these are the objects that we work with, arrays. And perhaps it's again obvious to work or at least employ linear algebra and see why linear algebra is so much involved in this part of data science is because when you do the programming, again, you can have functions or transformations defined over your vectors, your arrays, but really when you do the programming stuff, you really encode functions as matrices, right? Or at least vector operations. So as an example, if you have this function, a multivariate function, so we have n variables here, and let's just consider this a very simple function. So what it does is it triples the first value in the first coordinate and then adds it to twice the second and so on. So this is a very simple function that takes in your input and then converts it in some way. So it outputs a real number, right? So it's a mapping from R to the n to R, and it spits out one. It combines the input, the information that you got from your observation, it combines it in some way, and then it spits out a number, or that's the output of your function. But then if you think about it, and this is really what computers do, this representation can be rewritten in this form. So it's just really this vector here, the coefficient vectors, and then the variable, the values that will be put in the variables. If you transpose this array, this is just this polynomial here, this function, it's really just the vector product, right? The matrix product of this array with the transpose of this one. Or thought of differently, is just the dot product of these vectors, right? And this is what computers understand. So instead of thinking about the many processes involved in your function, so you have to triple the first entry, and then double the second entry, and then add the two arguments together, and then subtract the third entry, and so on. Instead of thinking about in all the necessary operations in your functions, you can just think about it as just one operation. It's just the matrix product or the dot product here. And so this is just for one function. So if you would like more complex functions, then if you have more functions involved in your analysis, then you can just compose functions as then matrix product, right? So if you this is just a visual representation of what I did. So again, your input is a vector. It's an observation with n-dimensional values, right? And in this case, perhaps you have many functions involved. So that's represented by the rows here. So this would represent one of these coefficient vectors here, arrays. And so the multiplication, the first row with this column would represent the output of the first mini function that you have. And then this one would, maybe you have a second function that you want to apply to the same data point, and it outputs its own object here. And so you can kind of stack together the functions that you have, right? Whatever the purpose of those functions would be, you can stack them up and just treat it as a matrix, right? So organize the coefficients into just as rows, and then simplify the operations in all the functions simultaneously as just one computer operation. Is the matrix product of this monster matrix with this column vector, and then you get the output here. So this is just a way to say that the way to simplify operations and functions defined over your data points would be just matrix multiplication. Really, that's the key here. So if you want more, and if you need to use more complicated functions, you just do more matrix multiplication. So here, if you, for example, for some reason you would like to convert your input, an r-dimensional input, to a multi-dimensional output of s dimensions, and then follow it up with another transformation to r to the t, and then so the function that you get essentially will be from r to the r, right, r-dimensional space to t-dimensional space, because this function and this function is represented by a matrix multiplication. Everything here, the function composition is really just a sequence of matrix products. And that's the language that computers understand. Okay, so that's the point that I wanna drill here, right? So, and this is something that I've heard many times in conferences, is that if you think about it at the basic level, data science is just really a bunch of multiplications, matrix multiplications in this sense. Okay, so here are some examples of matrix multiplication in action. So there are many things that you could do with this. So the dot, inner, and scalar products. Correlation and regression can be represented as well by matrix products. Singular value decomposition, which is important in compressing objects, especially, for example, JPEG uses SVD to compress the image. You could also do dimensionality reduction. One popular tool is PCA, and that uses at the core SVD and matrix product. Convolution, that's a fancy term, but and it's used in neural networks right now. And then PageRank, the Google's PageRank. And this is what I want to discuss. Oh, before that, so in this language again, so going back to this big picture, so once you understand functions as just a sequence of matrix operations, you now think of a model or a program as just a sequence of or systematic way to put together complex or complicated functions. So if you adapt this thinking, models now become just programmed compositions of matrix multiplications. And so you have a function, right? After this, you would like to optimize it. That's where calculus comes in. But before we go into that, let me give two important examples. Because again, my goal is for you to see the very detail on how mathematics is used, at least in these two very important examples. Hopefully, we're able to describe the general framework of data science and how mathematics comes in. But at least at these two examples, I would like to show at least how, in particular, mathematics in more detail is used. So ang gusto kong take away is that once you leave this talk, you've learned something new. And in particular, that's how to use mathematics, in particular, linear algebra and statistics in PageRank, in Google's PageRank, and in neural networks. So Google's PageRank, it's actually patented, I think, is one of the main reasons for the success of Google. It's named after one of the co-founders of Google, Larry Page. And what it does is it answers this question. So if you, I'm sure you've gone into Google, right? And you do searches. Halimbawa, go to Google, search community pantry near me. Yeah, so Google will do its thing, will do the work and find all the pages relevant to your search. But then the question is, how do you organize it? How do you rank? How do you decide which website goes on the top of the list? Because typically that's what people click on, the first Google search result, and then how does it decide on what to put next, and so on. Okay, so that's just what I said. And so here's the idea. So the assumption is that the World Wide Web is an asymmetric directed graph. So the circles here represent the websites, and the arrows here represent the link, so the connection. So there will be an arrow from website A to website B if A refers to B. So if in the website of A, there's a link that would lead you to website B. So that's the assumption. And so it could be bidirectional because website B could also link back to website A. So the question is that, so when you do the search, you have this result of all the relevant pages, and then the algorithm would look onto this network, this underlying network, on those related pages, and then decide and then ask itself, which one of these, or how do we rank all the vertices in this graph, in this directed graph, in terms of importance? At which website is most important with respect to that search that you just did? Which one should I put first? Which one should I put second, and so on? Just based on this information on the graph net, or in the network information. So one idea that you can possibly think of is that perhaps one website is important and it should be prioritized when you do the ranking if it's linked to many things, right? If a website is important, if many websites point to it, like for example here, and B, for example, A points to it, and then also D points to it. So perhaps B is important, but also possibly D, because B points to D, A points to D, and C points to D as well, right? But there's this tiny thing that we need to tweak here, because the problem in this criteria is that kung ganun pala na important ang website if many websites point to it, and then if I create a website, I'll just make several other websites and point those websites to my own website, and then if I follow this strategy, then my website will also will increase in importance in that sense. So to address that problem, medyo kailangan lang nating i-tweak to discourage that. We'll say that a website is important if many important websites as well point to that website. So if you think about it, that makes sense, kasi if those websites that are important refer to you, some of those importance really transfers to your website. So medyo circular lang, I would agree, kasi we say that a website is important, but then also use the definition of the importance for the things that point to it. So medyo, I agree, it's a circular definition, but hopefully it will make sense as we go along. So the idea is we would like to also capture that notion of transferring importance. So mas credible ka if other credible websites also use you as their source of information. Okay, so here's the algorithm, and this is where math comes in. So here's the network again. What we do is we associate the columns of, we form a matrix, what we call the link matrix, and this is really just the adjacency matrix of this directed graph. Okay, so the columns here would be refer to the website. So the first column here refers to the website A, B, C, and then D. Okay, so what do these numbers represent? I will put a number if there is an arrow from website A to halimbawa ito second row, that would be website B. Okay, so there is a number here because A points to B. Similarly, A points to C. Okay, so that's why there is a number here, and then also to D. So in a way, this. Hello? Is there a question?
Huh?
Okay, so I'll just continue. So in a way, this demonstrates that this is and we will normalize that. So there is a number here. So let me try to explain that first before I try to explain what is being passed here. So the number 1 or the number 3, that's the more important thing. So this weight somehow captures the relative importance that this website A transfers to the other website. So for website A, there are 3 options. It links to B, C, and D. So the probability of transferring this importance is 1/3. There are 3 choices. Right? So that's what these numbers represent. So 1/3 here says that, oh, coming from A, I have 3 options. I could go to B, I could go to C, and I could go to D. Similarly, with website B for the second column here, I have 2 options for B. I could go to A, and I could go to D. So that's why I will put at the 1, 2 entry. B points to A, so I will put a number here and also a number here because B relates to D. And what would be those? Well, I have 2 options for B. I could either go to A or to D. So the probability is 1/2 for both targets. Okay. Same is true with D. D only goes to, C. C goes to D alone. So only D has an entry here, and it's 1. That's the only choice. If you're stuck in D, there's only one way to go. You can only go to D. If you're stuck in C, that's what I meant. You can only go to D. And then same is true with the last one there. We have 1/2 here, 1/2 here because D points to, let's see, B and C. Okay, so that's what this matrix represents. And in a way, it captures the activity that's going on in this network. If you do a random walk, this is the probability that you will go from one object to the other one. Right? So these numbers somehow capture that information. So what we'll do with this matrix is that if we start with a ranking vector, so the ranking vector is R. So the initial guess would be, well, let's put 1/4 to everyone because we have 4 vectors and each one is equally likely to be ranked first. That's the assumption here. So that's the interpretation here. 1 in 4, 1 in 4, 1 in 4, 1 in 4. And then we will loop this vector using this equation. So we will iterate our ranking vector by multiplying it to our link vector. So remember, our link vector is this one. So starting with your initial guess of 1/4 everything, right? So equal probability, you multiply the matrix multiplication with this link vector to that initial one, and then do it again and again and again and again until it stabilizes, until it reaches the point that R sub I is not too different from R sub I plus 1. So in other words, if you go back to linear algebra, this just really means that we would like to get that eigenvector for corresponding the eigenvalue 1. So if you think about the next line to, but you can think of this equation as lambda R sub I plus 1 equals L times R sub I. That's the defining criterion of the eigenvalue. So we want this to stabilize. So in a way, what does this mean? So if you multiply this matrix on the left and then R here on the right side, you're trying to capture the effect of this matrix to that ranking vector. And then you do it over and over again until the point that it's nothing more changes. So anong interpretation nun? If you do it enough, some of the actions will not affect the distribution anymore. So if you, for example, if eventually you go to website B 100 times and then 99 times here and then 70 times here, a small increase in those numbers won't really affect the overall distribution of these probabilities. Okay, so that's the idea in this recursive definition. So after 10 iterations here, we see that this vector doesn't change much. And so the way we interpret this is that, well, let's see. So 12% of the time we land in website A. If you do a random walk in your network, right, in the worldwide network, 20% of the time we land in B, 24% of the time we land in C, but 40% of the time we land in D. And so this is what Google PageRank interprets as the importance. So the higher probability here means that, so if you do a random walk in the graph, you're more probable to land here. So we will interpret that as the importance of this website. So in this case, we were correct in the early guess that D was the important website. And so Google would refer, if you do your search and then Google does its thing and then it ranks and then it spits out the output, website D will be put first and followed by these websites according to the importance. Okay, so this will be the ordering. It could be B and C here because they have a similar importance. So hopefully you got the idea, and then and see that really it's really the mathematics that makes the process work. So to come up with a ranking, and it's very simple if you think about it. It's just matrix multiplication all the way, right, until you stabilize. So there's one caveat here, and I didn't want I didn't want to go in much detail there, but there is this one caveat. If you think about it, the World Wide Web is really sparse, right? Not all websites are linked to everyone. So really you have to, there's one corrective measure that you have to do here. It's called the damping factor. But that's too technical, I guess, but at least I wanted to mention that this is not the exact PageRank algorithm. There's this corrective step that talks about the damping. But in general, this is the main idea of the PageRank algorithm. And I wanted you to see that really mathematics is at work, even in the application that made Google, basically. The other one, so what are the other applications of PageRank? So I think they patented this PageRank. It could be used for other applications as well, because if you think about it, you just really need a directed graph. So if you have an object that you want to study and it's representable by a directed graph, and the relationships are directed, right? You could go from A to B, but perhaps not from B to A. You could use and you're interested is to see which one of those vertices would be most important, second most important, and so on. You could use okay, someone's writing, Ansonet. Okay, so you could use the same idea to come up with an analysis on which of your objects. So for example, finding goats, so greatest of all time, someone did this. So they analyzed, I think, basketball teams. And the relationship was that if team A beats B, right? So the vertex for B would point to A. So that's the relationship. So your vertices would represent teams, right? And then you can define the relationship, the directed relationship, however you want. And they were able to use it to identify the best team in the league. I think they also did this for tennis. The all-time greats. So they represented the tennis players as vertices, and then the same idea. If player A beats player B, then the vertex for player B would point to player A. And I think the result was that Jimmy Connors was the best player. And I don't know if they've updated the network, but that's the result. So that's one application of PageRank. It doesn't have to be a search on the most important something, but you can change the context. Another one is collaboration prestige. So I think if you write papers, you will probably write with other people, and then you can define the how do I say it? The distance between two authors in terms of their collaboration. So if you're familiar with the Erdos number, it's the number of steps that you have to go through to trace a path to Paul Erdos. So Paul Erdos is a mathematician, and for some reason he became the reference point. And so somehow the lower your Erdos number is, that represents the shorter path to Paul Erdos. So it's a measure of how close you are to Paul Erdos in terms of co-authorship. So you can try that. It's available in MathSci, I think mathsci.net. You can try to compute your collaboration distance. Okay, so I think what they did in this application is they tried to see which, relative to one person, right? Which one, well, at least analyze how close people are with respect to someone using their collaborative distance. Also, PageRank has been used to predict traffic flow, because if you think about it, the streets would be graphs, right? The intersections would be vertices, and the roads themselves would be the edges. So it could be one way, it could be two-way roads. Then you can use PageRank has been used to study that. And also, this one is very interesting. Neurons in the brain. They were neuroscientists were able to identify parts of the brain that changed together as the subjects aged. So there are portions of the brain that I would say that they work together, and then so if the function of one thing changes, so does the function of the other ones as well. So one nice application that has been done. So I encourage you to look it over if you're interested. Let's see how with time, 10:51. Okay. All right. So I wanted to use this to transition to the other one. One other important application of mathematics in data science, and this is really the main importance of this is that neural networks have been used heavily because of its efficiency in image classification. So at this time, it's really easy to generate images, right? So you can be swamped with a lot of images in social network. And one challenge is to try to identify the image just from the data on the data on the image itself without other tags or anything. Try to determine whether that picture shows a dog, a picture of a dog, a cat, or whatever, right? Or in more useful applications, it could be the detection of a tumor, for example, in X-rays or other medical imaging. So neural networks have been very successful in that approach. And I'd like to show, or at least share, what or how mathematics fits into this one. So the assumption of neural network is that it's modeled after the brain. So it's we're going to try to learn that this image, this thing here is the image of an 8. Okay, by following this network, following along this network, which is patterned after the brain. So the idea is this: so each circle here represents a neuron, just like a neuron in your brain, and then the brain, your neural system is connected. It will be connected in this way, and the idea is that the information passed by these neurons will be processed and transferred to another neuron, right? And then it might be how data is transferred from these neurons to one neuron in the next step might be different to the other one, right? And the idea is that if we choose, I didn't want to be technical, but if we train properly and if we put a proper neurons here, and I'll clarify what that means. The idea is at the end we'll be able to determine or learn, the network will be able to learn that this image represents the number 8. Okay, so again, the idea is you have a graph here, a connected graph here, and then the input layer will be your the data from your object. So in this case, this is a 28 by 28 pixel. So the cells here are represented by digits from 0 to 1. 0 if there's nothing there, if it's black, and then 1 if it's white. So, and then in this grayscale representation, the intensity of the color will be translated to a number. So from 0 to 1. So each of these neurons here will be represented by a number. So let's say this first row will be the first 8 neurons here, then followed by the second row, and so on. So this is 28 by 28 pixel, 28 times 28 numbers here that corresponds to the input here. So each pixel here will be an input neuron here. The idea is that we'll use everything try to process it using a filter. So here's the idea. To get to this digit, what we'll do is, so for the digit 0, perhaps, or maybe I'll focus on 8. For the digit 8, we'll try to identify features of 8, right? Identifying features of 8 that, or small identifying features of 8 that we could somehow piece together to form the number of 8. That's, di ko alam paano sabihin, pero I think that's the best way to do it. So this is better with pictures. So for example, this, we could use this part of 8. So we will consider that portion of 8 as one filter. And maybe perhaps this is another feature that distinguishes 8 from, say, the number 1 or the number 4. And then perhaps this junction here is another feature. So in a way, we're trying to break down the information from one digit, from this matrix, right, into different filters. And the idea is that once you have an input, right, we'll try to match this input, how close it is to the filters, to each of the filters. So for filter 1, here's filter 1. Okay, so think about this neuron as representing this filter 1. So what we do is we'll consider another matrix of the same size. Right, and if there's so here's your input. If there's, we will construct the matrix this way. So we'll make a matrix of we'll create a vector of 28 by 28 here, and then we'll only put values in that part that is shaded here. So everywhere else is going to be 0, but for this part it's going to be depending on the intensity. Right. So the idea is you want to capture this piece of information. Okay, so here you have an input matrix of 28 by 28. You also have another matrix here, and we'll see how similar they are. Okay, so the way we do it is just, so remember, each value here is just 0 or a digit between 0 to 1, right? The same here, because we own, for this neuron at least, we wanted this neuron to be to capture this information. So we'll represent these relationships here, will represent by this matrix. Okay, I'm trying not to be too technical here, but that's the idea. So here your input is a 28 by 28 matrix, and then for this filter, we'll try to compare this image with that image. But remember, this image is 0 everywhere except for that portion, and try to see if we overlay this to that one, how much of them are similar. Okay, so one way to do that is just dot product, right? So this is a 28 by 28 matrix. So is this one. So if you take the dot product, it's going to be a long number, a big number, right? So first entry here times the first entry here plus second entry here times the second entry here, and so on. And the idea is that since everything is 0 here except for that part, we'll see how that respective portion in the input, how similar that is to our filter. Okay, so if you do the dot product, that becomes a number, right? So that output will go in this neuron. The dot product is just a number. It goes to this neuron. But remember, our goal is for every neuron to have a number just between zeros and ones, right? So we'll deal with that in a bit. So for this filter, we get a number here, taken from the dot product of this and this one. And then if you do it again, if you choose a different filter, let's say this filter perhaps captures that there is this feature here. So again, match this image with this one. If they're similar, then take the dot product, it outputs a number here, and do it for everyone. And by the way, these filters, you can decide what they will be. They don't have to be from the digit 8 alone. Perhaps you can choose, say, a filter from digit 2 and then put it somewhere here to see how different that filter is from this input. Okay, so the idea now is that you have another layer of neurons. So you started with 784. You decide on how many filters that you will use to distinguish the inputs from the filters. And so you get a smaller row of numbers here. But, okay, so again, the goal is for every neuron to have a number between 0 and 1. The dot product may not produce that, because if you do dot products, you take the product first of the entries and then you add it together. It might be a giant monster. So the way around it is to map to map basically the real number line to the interval 0, 1. There are many ways to do that. The two most popular ways would be to use the sigmoid function here. So just plug in that, use this function to map. What it does is it maps the real number line. So that's what this graph represents. The output of that dot product could be anywhere here in the real number line, right? But what the sigmoid function does is it maps the entire real number line to just the interval 0 to 1 here. And that gives us a number that we could put in here. Okay, so same is true for this one. You do the same thing. Another option is the hyperbolic tangent function. Again, it maps the real number line, not from 0 to 1 this time, but from -1 to 1. And the idea is that perhaps you might want to include negative digits to demonstrate that there are more differences than just intensity of similarities. So these numbers can actually go from -1 to 1 if you want to capture that sort of information. Okay, so now we have a second layer. We do the same thing for this one. So again, if you take the, so you have, okay, sorry. So you do the same thing here, and then you arrive at at numbers at this last column here, right? So the idea is that we will interpret the resulting numbers here as the probability that that image is that number. So if the network was trained properly, then for example, this number 8, this neuron for 8 will have a high number, meaning close to 1, and then the rest will have lower numbers. So again, if you think about it, this is really just matrix multiplication again. So because you're mapping everything first from R to the 784, right? By dot product, you get this one, right? And then you do this one with this one. It's just another matrix multiplication. So from R to the 784, right? For this input, this is that layer. This is the input layer. This is that vector. You map it to R to the 10 first, and then you map it to another R to the 10 because we have 10 digits here. And so again, this is just really matrix multiplication all over again. So what you really get here is a function, right? So a function from R to the 84. You give me a picture of a number, I tell you what that number is, right? So it could be that. So the output is an object in R to the 10, right? So you have 10 coordinates there. So you can interpret this as if your problem is classification, the highest number would represent the membership in that class. So in our example earlier, if 8, the number in 8 here, the resulting number in 8 is the highest number, we'll interpret that as the probability that that input is an 8. Okay. If your model is a predictor, then for your input of 784 objects, you're approximating a 10-digit, your output in R to the 10 is an approximation or some representation of that input here. So it depends on your application, what would be the interpretation of this output. So, but this is, again, this has been used largely for image classification. So the 10 digits that you would get here, you would interpret that as the probability that that input is that number. That's interpretation. Okay, so that's the modeling part. So once you get a function, and this is true for the general case, you have a model now that takes care of your input and then spits out something, right? But it's possible that, and this is true for the beginning part of your modeling, right? That the output could be very bad, right? So again, your input could be this one, and then your output is this one. So this is really crappy because, well, let's say it could be 8. We're saying that could be 8, but it could also be, say, 4 and 3 and so on. And so the next problem then is, how do we improve this model? And that's where the next step comes in, the optimization, where calculus comes in. So the idea is that you have a function here, and then we know how to optimize functions, right? So going back to the naive example of optimization in real valued function. So just consider this is not C. This is just a function in the plane. And so if you try to remember calculus, how do we optimize a function, right? So in this case, we want it to be minimum because C here, so C here would be, so it's the cost we call it the cost function. It accumulates all the errors of your model from the ground truth, and then it spits out a number. Oh, this is how bad your model is, right? If it's a big number, and we want to optimize that. So in particular, we want to minimize that cost function. So it's back to calculus all over again. So it's the same idea for this very simple function. How do we find the minimum here? Well, if it's a very simple function, right, you can just, if you know the function definition, you just take derivatives. But here's one. But remember, C really lives in R to the 78. So perhaps there's a better way to find the minimum than our naive example, because we have 784 variables here. So the idea is that, all right, so if you can find the slope at this particular number, right? If you at that point, and you know that the slope is, say, in this case, negative, since you want to reach the minimum here, right? If your slope is negative, then you just go to the right. So you just move to the right. So I have this point, I compute the slope here, right? And then if the slope is negative, I've moved to the right. If the slope is positive, say for example at 0, then I move to the left. Okay. By how much? It's common practice to move approximate to move to the left or right, proportional to the slope that you get. So if you have large slope, you move large. You take large steps. If you come to a point where the slopes are becoming smaller, then you adjust. You move a little smaller. Okay, so that's the idea, and this is really similar to what we learned in gradient descent, and so we employ the strategy for high dimensional space, and we arrive at the minimum. And so that's how the general idea is that for high dimensional space, it's not easy to think about the derivative anymore, but you can still compute the gradient. So the idea is that if you can find the gradient at a particular point, then you just move in the direction of this one. So why is it negative? That's because the gradient gives you the direction of the high, or the steepest increase. Since we want to go to the minimum, you go to the opposite side by this much. So again, proportional to, or some factor of it. You move proportional to the magnitude of the gradient and in the direction of this gradient. So in that way, again, I know I'm sweeping a lot of things here, but again, I just wanted to you to have an idea of how the next branch of math would fit into the optimization of a machine learning algorithm. Okay, it's 11:08. So the last step would be, this is just an imagery of what's going on. So for high dimensional space, this is not high enough dimension. This is just R to the 3. But the idea is the same idea for this graph, right? So if the gradient is positive, then you move to the opposite direction proportional to the magnitude of the gradient. And then at some point, it might be slow, right? But at some point, you will reach a local minimum here. This is just an imagery of what's happening in high dimensional space. Okay, so for the last part, and I want to be quick about this. The last part is for the analysis and interpretation. It's back to the traditional statistics. So we have your model, you have your you optimize your model, and then you would like to test it into some or validate it into some data. And that's where, again, statistics comes in. So you could test the model's performance in terms of precision and recall if your task is classification, or if it's regression or prediction, you could also use the mean squared error. So at that, in that sense, we refer back to the established methods in statistics. So these are really the basic mathematics that's involved in a data science problem. So it's crucial that we can represent objects and processes in terms of ideas and objects in linear algebra, because really that's how we program it, and that's the language that computers understand. In the development of the model, there are many algorithms that's borrowed from statistics, established models that still make it to the realm of data science, because in how do I want to say this? In the history of data science, statistics was really a part of it. Right? It's not like, oh, here's data science and then we just try to borrow some methods from statistics. It's not like that. It is in the genes of data science that statistics is involved. So that's why we borrow a lot of models from statistics to employ it to methods in data science. And the idea is that since we have a computer science component, we are able to magnify the power of statistics with other ideas from mathematics and computer science. And then it's the same idea of once you have a model, it's just a function, right? So you optimize it in the same way that you would for other functions, and then you try to interpret and analyze the power of your model. And so that concludes my talk. I hope you're able to get an idea of how mathematics plays the role of the gear that keeps the thing going. And at least an idea of the fine details of how mathematics is used, at least for the two examples of PageRank and neural networks. So with that, I would like to thank everyone, and I am now open to questions. Celeste, how do we go about this?
Thank you, Sir Paul, for that very informative talk, lecture. So, saglit lang po. Sorry. Okay, so for our Q&A, you may post your question on the chat, and this will be asked by me, or simply virtually raise your hands, then I will call you. After I call you, you may simply unmute yourself and ask your question to Professor Paul. Okay. Okay. Wait lang. Hala, may nagtatanong ba? Ay, pasensya, may nagtatanong sa YouTube.
Celeste,
Ay.
pwede ako? Pwede
Hello?
magtanong? Willie. Na-mute ka, Celeste.
Hello? Hello?
Yeah. Pwede ako magtanong?
Yes, sir. Go ahead.
Sige, thank you. Thank you, Paul, for that. Yung nga sabi ni Celeste, very informative introduction on data science. I would like to ask something na probably our participants are wanting to ask, pero baka hindi lang maisip or baka nahihiya lang itanong. But I understand most of our participants naman are high school teachers. I would like to know if it's possible for high school students to do a research project on data science. Is this something that you think they can handle? And if yes, can you give us some ideas kaya on what possible research studies that they can do as high school students?
Yes, thank you, Sir Willie. I sincerely think that yes, they can, especially for those who have taken courses in programming, right? Because that's really a skill that that's important. But if not, we can also always form teams to complement the skills of everyone. And I think we're at a level now that, at least in resources wise, there are many resources available that you can actually teach yourself about the important stuff or the basic stuff. So it really depends on the scope of the problem that you would consider, right? So I just don't know the background of or the curriculum for the high school if um, at halimbawa yung sa coding part, I'm not sure if there's enough input in the high school curriculum about that part. But if there is, definitely the other concept can be learned on their own, or at least with the supervision of a collaborator. Yeah.
Thank you.
In terms of
Oh,
the project, you could always start with a vanilla problem, right, and then go from there and improve the problem. The some of the usual first project that you could work on would be classification tasks. So you have so I worked at MSRI for a bit, and these are undergraduate students, right, in Berkeley. So the problem that we worked on would be it's a machine learning project, right? We took data from ECG, and then they developed a model for classifying ECG based on I think it was four types, whether it's the ECG is normal, it has atrial fibrillation, it has other conditions, but it's not normal, and then if the ECG was too noisy or too dirty. So, and they were able to do it. So it's for that reason that I think high school students can complete a project in data science, because when you have the skill, at least the basic skill there, if the basic skill is there, the theoretical component can catch up because we have many resources available now, at least online. So I would say yes. And the first types of projects would be the vanilla classification projects, or even I would say regression or developing predictive models.
So follow up lang, Celeste. So parang imperative ba na or necessary that for our high school students to be able to come up with even simple data science projects, they need to have a background in calculus, statistics, computer science, and is linear algebra a must? I'm not sure kasi if it's being taught in high school now pero I'm sure stats and calculus siguro, and then computer science maybe they can study it, or some of them have already a background on it. Pero I'm not sure if linear algebra is being taught in high school. Maybe our teachers can validate. Yeah.
If it's like bare bones, if you're asking about bare bones na skill to be able to succeed in a data science project at the high school level, at the very least experience in programming.
Okay.
Yeah, because the theory under linear algebra would make sense when you start programming. Handling data, cleaning data, processing data. The linear algebra would make sense, and why you need it at that portion. So, yes.
Yeah, thank you.
Okay. Ma'am Vel?
Yes, thank you, Celeste, no? Thank you, Sir Paul, sa maganda mong lecture, no? Very informative. At least you've given us an idea on the data science, no? Ang tanong ko actually parang natanong ni Sir Willie, no? my question should have been kasi yung tanong niya para doon sa mga estudyante, no, that who will be wanting to do a research on data science. And then gusto ko sanang i-extend yung tanong niya on the teachers, like secondary and tertiary teachers who also wants to advise these undergraduate students or even the secondary students. So parang nasagot mo naman na you need a little of linear algebra and programming, no? So extend ko na lang ulit, no? If this our participants, no, who wants to enroll in the graduate program in mathematics, no, kahit sa MS or even in MA or PhD mathematics, no, ano yung pwede nating gawing motivation, no? To be able to, well, to be able to give them or to motivate them, or they have their interest to do research in data analysis. So, pwede siguro yung personal experience mo, no? The question would be, ano ba yung naging motivation mo? Bakit naging data analysis ang inyong expertise ngayon?
Okay. Thank you, Ma'am Vel. And that's really how I wanted to approach it, yung experience ko sa research in relation sa data science. So as a motivation for those who are thinking about enrolling in the EMS program, there is, at least in my research area, there is a very new development. I work in topology. Traditionally, topology has been very theoretical. It's either you work on the pure side of topology or algebraic topology, and that's what my PhD work was on. But there's a new trend in topology that actually applies it to data analysis. It's called topological data analysis, and the idea is that we will leverage topological information that we can extract from data and see if we can get something useful out of it, and we could use it for data science or for data analysis. And there's a lot of promise. There's a lot of work that's involved here. And in UP Baguio, I have 4 students working on TDA, and so in terms of motivation, there is the capacity and there are opportunities for research, in particular to this area because it's very young. A lot can still be done. And just to give you an idea of the things that we're working on, how we marry the pure side of topology and the application to data analysis. It's still related to that project that we did at MSRI when I worked there for 2 months. We were able to generalize that to the full use of the ECG, because what we did before, so MSRI, because these are just high school students, we really just had 6 weeks to work on the project. It's a smaller data set, and we only had input from the first lead of a standard 12 lead ECG. And so what we did in UP Baguio was that we took that to the next level. We were able to use the full 12 lead ECG and put it in the framework of that theory of topological data analysis to come up with another classifier that could now that could take in the full 12 lead ECG. So if you, I'm sure you're familiar with an ECG, right? So if you do an ECG, yung strip of paper that has 12 waves that come out of that strip of paper, that's your input data from that. And then we were able to develop a model that would say, oh, there's a big chance that you have this kind of condition. And from 4 types of conditions that we used in the MSRA project, we were able to increase that to, I think there were almost 28 conditions that we were able to include. And in fact, this is part of a proposal that I haven't quite, dapat i-revise ko na yung proposal ko kasi it's for funding. But that's one thing that we can continue working on. And there's a prospect for funding on that. Yeah. And another thing that we are working on, again, to give I guess to serve as motivation, is that we are also into development of new methods. We are, again, TDA is very young. It's less than 20 years. Data science is also very young. It's also less than 20 years. So we're trying to marry together. So part of it is the development of algorithms and computational tools that will speed up. Kasi ang problema ngayon, yung bottleneck is the high computational time. So data is very complicated. It lives in very high dimension. And then even the processing and how you collect the data is also expensive. So one other area that we do in the department, at least a TDA group, is to develop computational tools and develop algorithms that will remove that obstruction of computational limitations.
Okay. Question po from Sir Matthew Mariani. Sir, are there available free online crash courses for data science where we further capacitate ourselves?
There's a lot. Actually, I think there was one blogger that what he did was he collated all the useful and sought after tutorials. There are some from Coursera, from Udemy, and I could include that into an email if I can how do I share that? Because so the short answer is yes, there's a lot, but of course you would want to ano ba? The problem kasi sa ibang tutorial is it's focused on just one thing. So halimbawa may mga tutorials na masyadong focus sa programming without learning the theory. So that could be dangerous, right? Because you can do stuff but really don't know what's happening. So I would just caution everyone to, yes, there is a lot of information available out there. There's a lot of tutorials, but just be careful on being too excited to jump the wagon and just do things without really learning the foundation. So I could give some recommendation as to a good list of references and resources that could point you to the right direction. And perhaps I could ask the organizers to just send that to everyone.
Hello. Another question po from Sir Samson. How can we strengthen mathematics research? What other research topics you can suggest po?
Medyo broad yung tanong na how can we strengthen mathematics research. Pwede po ba akong maghingi ng follow-up question doon or clarification anong context niya? Sir Samson? Siguro in general na rin din yung ibibigay kong sagot. How can we strengthen mathematics research? If this is in terms of capacity, UP Baguio is open to collaborate with faculty from different institutions if that's the context of the question, right? As I understand that, yes, we may be eager to try to learn this, but the problem is how can we find partners to guide us, di ba? So one thing to, I guess, kaya nga ganito yung ating team ng SINSM is to really impart yung capacity. But if it's more than that, we are still open to collaborate, and I guess in that sense we can strengthen yung capacity ng institution for conducting these kinds of researches. I hope I was able to answer yung question ni Mr. Samson. If that's the context ng tanong na how can we strengthen yung math research in terms of capacity building, this is one way that we're trying to accomplish that. But we're also open to collaborate and or in some other ways to increase capacity.
Question po from Sir Akoba. Sir, is mathematical modeling through regression analysis also part of data science?
Yes, because so if you saw the slides earlier, data science is really a broad term, right? It's a marriage of mathematics, statistics, and computer science, and in fact, even analysis, right? When you do the optimization, so inherent yung type ng model that you would use is not limited to statistics, right? So it's any kind of model. Yung general idea ng data science is that you have a big data, right? And you don't know how to approach it, right? But you can borrow established models from anywhere, right? And try to fit that model into the big data with the help of programming and computer science. So definitely, yung usual notion ng modeling would fit into the framework of data science kasi nga hindi naman siya talaga separate. It's more of a unifying theme in data science than a divisive thing.
Okay. Maybe this will be the last question. Um, how does data scientist, data engineer, and data analysis differentiate from each other in terms of the actual and degree of difficulty of these works? This question is from Sir Robin.
Yeah. So again, these are very ano ba? In some sense, in some context, they are interchangeable. Yeah, but and there is actually ano ba tawag doon? May argument dito eh. Yung difference nga ng, and this is a real question even sa field, sa industry, yung how can you call yourself a data scientist, di ba? Ang generic answer would be yung the data scientist really is involved in the entire process of and I would answer this in the framework of how a data scientist in the industry would answer this. So the work of the data scientist would start at the very first step na kasama yung iyong client, di ba? You would talk to them, and this is what they have as data. This is what they want to try to see, right? Kasi yung data engineer and data analyst, they have a they have in some sense they the problem of data scientists is that again they are overwhelmed with data. We don't have to process it, but to I guess the keyword is to tailor, right? How a data scientist would be involved in even in the tailoring of the project to generate really useful information from that overwhelming data to something that could be useful doon sa purpose ng client. And sorry for using the word client, but that's the easiest way to explain it. Yeah, so mas yung data scientist mas maraming ay, at least sa akin ang tingin ko kasama siya sa buong process eh. As opposed to other analysts na particular na yung kailangan yung tingnan. But I acknowledge that there is really a discussion on this, on what is the difference between the terminologies.
Okay. Thank you, Sir Paul. For more questions, you may directly ask Sir Paul, Professor Ignacio. So, oh no.
Celes, nasan ka na? Hello,
Hello,
sir.
hello.
Nawala yata siya. Celes, nandiyan ka pa ba?
Yes. Ay. Yes po. Hello, hello.
Yes, we can hear you, Celes.
Sorry, we have having technical issues. Saglit po.
Okay. Celeste, may I have some few announcement, no, while we wait for Sir Celeste to come in. As part of the evaluation or evaluating the plenary talk of Dr. Paul Samuel Ignacio during this 26th Summer Institute in the Natural Sciences and Mathematics, kindly accomplish the evaluation form by accessing the provided link here in the chat box. Kindly double check your full name and email address. Your full name will appear on the certificate. Once accomplished, you will receive an email containing your e-certificate. Okay, are we in now, Celeste?
Hello, hello. Okay, for everyone's convenience, ang ating evaluation form po ay pwede rin natin ma-reach through scanning this QR code. So maybe I'll give a minute para i-scan nyo po ito. For everybody's convenience na. Oh, okay. We're now going to um, reward Professor Ignacio his certificate. Sir Francis, kindly flash the certificate. Okay. We're now going to um, reward Professor Ignacio his certificate. Sir Francis, kindly flash the certificate. So here's the certificate. I'm going to read it. Summer Institute in the Natural Sciences and Mathematics, College of Science, University of the Philippines, Baguio, awards this certificate of appreciation to Dr. Paul Samuel P. Ignacio for his valuable input as plenary speaker during the seminar workshop and Mathematics
26
College of Science, Summer Institute in the Natural Sciences and Mathematics. Awards this certificate
to
of
the team
appreciation to
upgrading
Dr.
senior high
Paul
school
Samuel P.
science
Ignacio
and
for his
mathematics education.
valuable input as
Content
plenary
and
speaker
competency
during the
part 1.
seminar workshop
Held
and
via online
Mathematics
conferencing
Summer
platforms
Institute in the
on
Natural Sciences
and
and
8
Mathematics.
May
Awards
of
this certificate to
2021.
the team
Given this sixth
upgrading
day of
senior high school
May
science
2021
and
at Baguio
mathematics
City,
education
Philippines, signed by Professor Rizabel C.
during
Adawe, PhD,
seminar
person, held
and
via online
conference
Professor Dimna
platforms
and
on
Javier,
natural sciences and
P.
mathematics. May
PhD and
of
Dean of
2021
College
to
of
the team
Science. Given this sixth
upgrading
day of
senior high school
May
science
2021
and
at Baguio
mathematics
City,
education
Philippines, signed by Professor Rizabel C.
during
Adawe, PhD,
seminar
person, held via online
conference
Professor Dimna
platforms
and
on
Javier,
natural sciences and
P.
mathematics. May
PhD and
of
Dean of
2021
College
to
of
the team
Science. Given this sixth
upgrading
day of
senior high school
May
science
2021
and
at Baguio
mathematics
City,
education
Philippines, signed by Professor Rizabel C.
during
Adawe, PhD,
seminar
person, held via online
conference
Professor Dimna
platforms
and
on
Javier,
natural sciences and
P.
mathematics. May
PhD and
of
Dean of
2021
College
to
of
the team
Science. Given this sixth
upgrading
day of
senior high school
May
science
2021
and
at Baguio
mathematics
Okay.
City,
education.
Philippines,
Thank you very
signed
much,
by
Sir Celeste.
Professor
I
Rizabel
think
C.
the
Adawe.
several echoes are made for a purpose. There are 269 as of this time. There's 269 participants. So I think we have to echo the lectures of Dr. Several echoes are made for a purpose. There are 269 as of this time. There's 269 participants. So I think we have to echo the lectures of Dr. Several echoes are made for a purpose. There are 269 as of this time. There's 269 participants. So I think we have to echo the lectures of Dr. Several echoes are made for a purpose. There are 269 as of this time. There's 269 participants. So I think we have to echo the lectures of Dr. Several echoes are made for a purpose. There are 269 as of this time. There's 269 participants. So I think we have to echo the lectures of Dr. Several echoes are made for a purpose. There are 260. We have to echo the lecture. Dr. Several echoes. SINSM Secretariat, baka pwede nang i-out yung ating live screening. Thank you. Thank you, everyone. We'll see you this afternoon, 1 o'clock po. Please go to your respective tracks.
Salamat po.
Thank you, Sir Paul, and congratulations. You're done for the day. Thank you.
Thank you po, ma'am.